All right. So let's try this again. Please alert me again if it pops up again and I'm talking. So we're gonna start off. I did ask you to pick up your packet. I did ask you to take out your ESRT. Danny, this is you too. Where's your ESRT? All right. Yeah, anyone else who didn't take it out? Sorry, Danny, just to single out you. And you, and you, and you. Take out your ESRT. Okay. We have started minerals in lab. It's not ideal. Normally, I would have started minerals in class before we started them in lab, but we didn't. So for those of you who've been struggling, maybe yesterday, today, maybe the day before in lab, depending on who you have, hopefully after today, the lab will start making more sense. And let me say, if you already started lab and now you realize you messed something up, please go back and fix it. Don't just leave it because you already did it. So hopefully this will make more sense. So what I'm talking about, for those of you who don't know what I'm getting at, in lab, we are handing you a mineral and saying, hey kid, tell me the name of this. And doing that is a lot like playing the game that I have here on the board. You guys remember this game?
Yes.
It's called Guess Who? Don't be an idiot. So playing Guess Who, do you guys remember how you play? What do you do to play Guess Who? Danny. How do you go down to narrowing it down? You take guesses. And your guesses are yes or no questions. And how's this question? Is your character a professor in college? Is that one of the guesses you use? Does your character have children? Is that one of the guesses? No. What kinds of questions do we ask?
Content-based questions.
Color hair. What's another one?
Skin tone.
Skin tone. Eye color. Gender. We always talk about facial hair when I play with my kids. Whether they have hats, whether they have big noses. What are these things called? Characteristics or properties of these people. So you ask questions that you can observe, not ones you have to make guesses about. So flat out hair color, nose size, hats or no hats. Identifying minerals is very similar to playing Guess Who. At my house, when we play, almost always the same first question pops up. We usually talk, and I know this might not be politically correct anymore, but my Guess Who, this is this exact one, and it was mine from when I was a kid. So we're talking about from the 80s. The first thing we ask about, is it a boy or a girl? And we stereotype it, boy or girl. Why is that the first question? Because it is. Now, also, you may note a problem with games from the 80s. What do you notice about boy versus girl up here? That's not it. From this board, how many boys are there? How many girls are there? Not a lot. They have, I've heard in the newer versions, updated this so it's more equal. But even if it was equal, it usually would knock down at least half. So it's a good first question. So let's go with that. Is it a boy or a girl? So that would get rid of, sorry, Anita. Sorry, Claire. Sorry, Maria. Sorry. Susan's out of here. Is that it? Are there truly only 4 girls in this game? So we even have a newer one. I know this. I play a lot of Guess Who in my house. Oh, sorry, Anne. I don't see Anne. Oh, didn't see Anne. Did not see Anne at the top. Okay. I hope I didn't miss anybody else. I don't want to leave anyone out. That's really, now, that's all. Was that helpful if you had a boy? No, if you had a boy, does that give you who it is? No. When you're playing, don't you always hope the other person has a girl? Why? Because then it makes it easy. We only got 5 choices then. You're probably going to win if the other person has a girl. The same is true on this mineral identification chart. So first thing you do is you ask a good question that's going to knock a whole bunch out. Then what's another question you might ask? You might ask about blonde hair, and if they do, we've got a few left. If they don't, we can knock out quite a few. Not blonde, this whole bottom row is gone if they don't have blonde hair. Most of this row. So you just keep asking questions until you knock out possible choices. The same is true on the mineral identification chart. So if you could take that out in front of you now. So everybody get your mineral identification chart out in front of you. Yeah, oh yes, if you haven't already started this in lab, it is the last page. So first thing I want to say is you need to have this out in front of you because I know mine is too blurry for you to read. It's too far away, but I want to have the whole thing in front of me. What? Yes. So to have this in front of you, I'm going to point on mine, but you need to look on yours. This is very similar to playing Guess Who. Yes, it's not arranged on a nice board that you can lay ones down. That would make it really cool if it was, but it's not. It's the same concept though. So in this one, they put the questions. Now you don't get to pick what questions this time. So you always are going to ask the questions in the same order. What's the luster? What's the hardness? Does it have cleavage or fracture? What's the color? And then any other distinguishing characteristics are in the next column. So you do have to ask these questions in order, but it's the same thing. So you will knock down, like if your mineral has metallic luster, it's a lot like the other person being a girl. Because if you knock down the if they have metallic luster, you only have 4 left standing. 5 technically, if you consider this one that has either. But having non-metallic is similar to being a boy. You have a lot of choices left. So before we can get into using this a lot, we need to make sure you understand what luster is, what hardness, cleavage, and fracture, and the colors are. So we are going to take some notes, and I'm not starting on page 1 in our packet. I know that's weird, but I want to get this out of the way so that you have it for class or for lab when you go. So we're going to start on page 2. Yeah, go ahead. We're going to start on page 2 of the packet. And it starts off with starting off here. And we're going to start off with the properties of the minerals. From your reference table, what are the properties of a mineral that we care about for identifying minerals? Right. Just like what are the properties we want to use for Guess Who? The first thing we want to use is luster. So fill that in. Then we care about hardness. We're just going to go right around the top. Do I fit cleavage and fracture into one? I call it breakage. Breakage means cleavage or fracture. If you want to put that down here, you can. What else do we care about? Color. But you're right, it's not that important. We'll get to that. Now, the last one we care about, I know this one says distinguishing characteristics, but the one where the specific distinguishing characteristic that we're going to talk about is streak. So I would like you to have those 5 things listed there. So these are the 5 characteristics that we care about. We are going to be looking at a mineral's luster, hardness, breakage, color, streak to decide the name of that minerals. We're going to use those characteristics and this reference table, and you'll be able to name about 20-ish minerals this year. And that is the goal, is that I can hand you any of these minerals and you can tell me the name of them. And that's what we're going to be practicing in lab. Before we get started, I want to talk about how these properties come about. Like, what makes a mineral hard? Like, why is a mineral hard? Why does it have cleavage and not fracture? Why is it metallic and why it's not? And the reason for this, and this is a big, like, important phrase. So big letters, star it, bold it, capital it. The reason for all of these characteristics is called the internal arrangement of atoms. I'll write that out. Internal. You must know this phrase. So again, the reason why they are their hardness, the reason they have cleavage or fracture, the reason why they're metallic or non-metallic is determined by the internal arrangement of atoms. But what the heck does that mean? Internal arrangement of atoms. What do you guys think? You guys know what an atom is, or you know the idea of what an atom is? Yeah. Inside, good, you got the internal. So what does internal arrangement of atoms mean? It means how the atoms are arranged in a mineral. So it really just, it does mean how they're bonded together. What shape do they make? So you would think that these properties are determined by what it's made out of, but it's not what it's made out of, it's how it's made that's important. So not what it's made out of, but how it's made out of. And just a side note here, these, yeah, this is kind of small, I'm sorry. These properties are used to identify the mineral. I'm going to do the rest on PowerPoint, so you won't have to figure out what I'm trying to say. So we did already talk about these in lab, so a lot of this is going to sound familiar. Share screen. The first thing we're going to talk about is luster. Luster is officially the way that a mineral reflects light from its surface.
Minerals are so cool.
Don't. All right, so what are the two choices for luster? Metallic and non-metallic. So what does that mean?
Shiny. Idiot.
So Jake is in on one of my pet peeves, and I'll explain it in a second. clearly a few others. Luster has two choices and only two choices, metallic and non-metallic, which means looks like a metal or does not look like a metal. As Jake has alluded to, shiny is not a good answer. Yeah.
What about the dude from Moana that sings the shiny song?
Lisa, I'm not really super familiar with Moana, but we're talking about minerals, nothing else.
Yeah.
So no. Stop it. Minerals. The reason I don't like the word shiny is when we're talking about metals, are all metals shiny? No. Are all things that are not metals not shiny?
No.
No. Diamond is the perfect example.
That's why it says light metal.
Are diamonds shiny? They should be. Oh, that camera's not on. It should be shiny. Should be maybe sparkly. So I see, so maybe somebody didn't like the word shiny for diamonds and you would have used the word sparkly. They're practically the same thing. So my kids have started using the word ducking to describe, or they describe their sister as a itch. And they use the word ducking when referring to that itch. So they call their sister a ducking itch. Yeah. Sometimes it's fluffing itch.
I would discipline them.
What, you guys, I know what they mean. Okay? You know what they mean? I know what they're implying. The same way with when, like, you might hear me say, what the freaking heck? I think you guys can think of what I'm saying in my head when I say that. Sometimes my freaking students drive me crazy. I don't want you replacing the word shiny with a word that means practically the same thing. Shiny and sparkly, yes, they're not quite the same. Just like ducking and aren't quite the same thing, but they mean the same thing. The reason I'm saying this is because if you use the word or even think the word shiny when talking about minerals, you're going to get yourself in trouble, just like if you dropped a big old F-bomb in the middle of my class. Be quiet. I will not yell at you. I will not write you up, but you're going to get yourself in trouble. And I use quotes because what I mean by trouble is you're going to screw up on the reference table. If you think all shiny things are metals, you're only going to be looking at the top part of the reference table. The top four. If you think all non-shiny things are non-metals, then you'll only be looking at the bottom. We'll talk about that one. So what I just want you to think about is all metals. Yes, some metals are shiny, some are sparkly. Gold, silver, copper are very common metals. But one metal I want you to think about is, have you guys ever seen cast iron? It's the metal you would use to cook on a campfire. You don't use your regular old aluminum pans on a campfire. They don't work. So you would use those campfire ones. If you don't know what I'm talking about because you don't cook on a campfire because you're not crazy like my mom, think of one of those big old witches pots. You know, it's Halloween time. You know what I'm talking about? Those big black cauldrons that they cook the children in. Yeah, they cook the children in. Are those shiny? No. Are they made of metal? Yes, a real one, not those plastic ones you put candy in, but the real ones are made out of metal. They're made out of cast iron. So not all metals are shiny. So there we go. That's my little speech. That's why you can't say shiny in this class anymore. The next thing we're going to talk about is hardness. Is hardness hard and soft? Is that what we're talking about this year? Who remembers from lab? It's how easily, it's a measure of how easily a mineral can be scratched. Write that in the box if you haven't discovered that already. It says define hardness. It is a measure of how easily a mineral can be scratched. So if I take my car key and I scratch it along the person's car next to me, what's harder, my car key or the car? The car key. Who's gonna leave a big old scratch, right? That's the concept here, is we're going to be using objects to scratch minerals. And if it can scratch it, it's harder. So here's in the explain how. If a mineral can scratch an object, then the mineral is harder than that object. If not, it's softer. Yep. So we're going to actually be using some objects, and we talked again about this in lab. We know the hardness of many common objects. Actually, I see a lot of you still writing, so I'll wait. All right, so like I was saying, we know the hardness of several common objects. You don't need to write this down. You do not need to memorize this. This will always be given to you. But one object is your fingernails, your actual fingernails. You will use them to determine if you can scratch a mineral or not. So you will take a mineral, and try to scratch it. So don't use the mineral to scratch your fingernail. That's going to ruin your fingernail. So you're just going to use your fingernail to scratch an object. If your fingernail can scratch it, which Renee's going to have to be your judge because she's real close. Renee, what do you see? I am scratching it. My fingernail is scratching this mineral. What does that mean about this mineral? It's softer than my fingernail, which you can also now say it's softer than 2.5. There are some other common objects, like a regular old penny. So if your penny can scratch it, you know it's softer than 3. There's not much difference here. That's why we'll usually just stick with your fingernail. But if you do need a penny, they are around. We have nails. So actual nails, not fingernails, but a nail. This has a hardness of 4.5. So again, you'll see if it can scratch it. If it does scratch the object, then you know the object is softer than the nail. Now the glass plate's a little different. So I have a piece of glass. I do not want you to try and use the piece of glass to scratch it, because that's could potentially break the glass. And I don't want a sharp piece of glass around a bunch of 10th graders. That never ends well. What I do want you to do, if you are ever determining the hardness of an object and you have a piece of glass, we'll go this way with this. So if I have the mineral and I have the piece of glass, I'm going to use the mineral to scratch the glass. Now this one does nothing. So what do I know about this rock or mineral? Softer than the glass. It can't scratch the glass. Good. But I could grab a different mineral. So I have this mineral and I'm going to scratch the glass. Now notice I'm not holding the glass in my hand. Because if I'm holding the glass in my hand, I'm using it to scratch, could potentially break, then there'd be blood, then I'd need to do paperwork, then I would be mad at you. So put the glass down. Scratch it. Sometimes you do need to put in some actual force into it, and it did scratch. I know you couldn't see it when I did it, but there's the scratch. If one of these breaks, please tell us. We won't be mad. It's a piece of glass. Glass frame. Again, I don't want you bleeding because then I have to do paperwork. So just let me know, and that way I can replace it if I need a new one. That hardness, you determine whether something can be scratched or not. The next one. There is this thing called the Mohs scale of hardness. With this, there are 10 common minerals that they just know the hardness of. So instead of using a kit with your fingernail and your copper penny, if you wanted to do this real high tech, you'd have a piece of talc and you'd know that was 1. You have a piece of gypsum, you'd know that was 2. And calcite, you know that's 3. And so you can use those to scratch unknown minerals. So it just gets it a little more accurate. The key here is that diamonds are the hardest. So what does that mean can't happen to a diamond really? Can't get scratched. That's different. I want to point out scratching and breaking are 2 different things. Diamonds can be broken. So they can get cracks in them. In fact, I actually have a crack in my diamond. A little chip out of my diamond. Yeah, you can take an iron nail to a diamond and it won't scratch. But you could break off a chunk of it if you hit it the right way. So I did not put any pressure on mine when I did that, but you can. I can take this, same deal. I can take the iron nail, oh, I put it back, to a piece of glass. That I'll prove to you. I don't want to prove it on my diamond because I could break it. That it won't scratch. Can't scratch it. Okay. But again, if I got the edge of it, I could chip a piece off. So there's a difference between breaking and scratching. So somebody's like, well, so you mean I can't throw this at the window? You know, you could break the window, but it's something like if you shot a nail out of a nail gun through a window, it's breaking. Breaking and scratching are 2 different things. Don't use them interchangeably. Speaking of breaking, that's where we're going next. It's called breakage. And we have 2 choices for breakage. Oops, am I sharing this? Trying to record this lesson. A couple people out this week. So breakage is exactly what it sounds like. It's how it tends to break. But there's 2 types of breakage, and that's cleavage and fracture. Cleavage and fracture is the tendency of a mineral to split or separate along flat surfaces. This is very useful because about half the minerals have cleavage and about half of them have fracture. I know that when you guys hear the word cleavage, your first thought is not talking about rocks. I do want to relate that type of cleavage that most of you are thinking about. That type of cleavage has a straight line in it, correct? Okay, I'm not getting into details, but there's a straight line in cleavage. There is a straight line on minerals that have cleavage. So when you're thinking about cleavage, you're thinking about straight lines. Minerals that have cleavage have straight, flat lines on them. I'm going to show you one. It's hard to show this up on the screen. I'm going to do my best. I should probably put this black thing on. Does that help or make it worse? Light, maybe the light will help. There we go. This guy right here, straight and flat.
Cleavage.
Straight and flat. This has cleavage.
Non-metallic.
It is also non-metallic. If you look at the sides here, straight and flat. One thing I do want to show you is it is kind of not, it's a little rough and bumpy on this side. As long as there's cleavage somewhere on the mineral, you say it has cleavage. So if one side's cleavage, but the other side's rough and bumpy, it's still cleavage. Notice how this one broke. What shape would you call that? A rhombus. It is also a parallelogram, but the type, so is a square. This is a rhombus. What is a rhombus? Okay, wow. I call it a tipping over square. So it's a square. It's a square that looks like it's leaning. See how we got that shape right here? I didn't cut this way. No one cut it this way. It came that way. If I was to drop it, which I actually, here's another one of them. Same kind of mineral. Oh, let me flip it that way so it's the same rhombus. It's not quite as good. But here, I broke this one yesterday. Maybe this isn't the best example. Let me see if I have a broken piece of it here. Every single one of these. Now this one's got some more broken edges, but you can see it was a rhombus. There's another one. Every single one of these has that rhombus shape to it. Some of them aren't perfect, like this one's not perfect, but you can see it was a rhombus. The key is it did a little push. Sorry, I get excited about little things. Take a look at that little tiny one. Another little tiny rhombus. Now, what you might see then when you pick up this, it's going to be bumpy and rumpy. Rough and bumpy on the top. But if you look closely, you can see that the break goes straight down and straight over in a little rhombus shape. So you got to look at where they're broken. Are they broken in flat, straight sides? Anytime they have those straight breaks, it is cleavage. So again, you do have to look closely because if it's bumpy at first, but then you got to look at those bumps and you'll see that those bumps go straight down and straight over. So that's going to be cleavage. Fracture. When I hear someone, if I gave you a stick and I said, could you fracture this? What would you do to it? Break it in half. How would you do it? I'd snap it. And how's it going to look? Because it's a stick. Broken, really broken to me. It's going to look like it's going to look like a huge mess. And that's what fracture is. No rhyme or reason to how it broke. Fracture is when the mineral breaks all rough, lumpy, and bumpy. I just like the way that sounds. Lumpy, bumpy, and rough. Oh, yeah, and rumpy. All right, we just will finish up color and streak, hopefully. So color is the most easily observed property, but it is the least useful. So write that in for color. So why is color not useful? Hang on, let other people talk. Riley, we got. Many minerals can have the same color. I have 10 minerals here for lab this week. These three are different minerals. What do you see about them?
They're all whitish clear.
They're all whitish clear. You're even using my words. They're all whitish clear. We have these three, which are all three different minerals. They're all blackish silvery.
Shiny.
So, I like that word.
So shiny.
So color, that's one reason. Another reason is these three are all the same mineral. So some minerals can be multiple different colors. These three are all different kinds of quartz. So color, while it's easy to see, is not super useful. So along the same line as color, we have streak. Streak is the color of the mineral's powder. It's really important that you always test the streak because it's not always the same as the actual color. All right, so we are just about done. You have no homework. Hopefully that helps you a little bit in lab.